Okay, so now we're ready to simplify radicals using addition, subtraction, and a little multiplication plus some exponents. So let's go to work. We're going to start with 6 square root of 5, and we're going to multiply by 2 square root of 3. Now when we multiply these, we can multiply the 6 and the 2 together because they're outside the radical. That gives us 12. Now the next thing that I have to do is multiply what's inside the radicals. And when I do that, that's going to give me the square root of 15. Now, in this case, I'm done. I always have to check this square root of 15 to see if there's anything I can take out of square root of 15 that's a perfect square other than 1. And in this case, that answer is in simplest form. But this one won't be. Here comes 2 square root of 6 times 5 square root of 3. So once again, we're going to multiply the 2 and the 5, the front numbers, the coefficients of the radical, which is 10. And we're going to multiply the square root of 6 and the square root of 13, which gives us the square root of 18. So with these two being multiplied, we have to take a look now at the square root of 18. Well, 18 is actually the square root of 9 and the square root of 2. I'm going to bring down my 10. I can't simplify the 10 because it's not in the radical. I keep the 10. The square root of 9 becomes 3. The square root of 2 I don't know because it doesn't have any perfect squares. So this breaks down all the way down to 30 square root of 2. How can we add radicals? Well, here's 4 square root of 3 plus the square root of 3. Well, there's a number in front of the square root of 3, and that's a 1. To add and subtract, we have to have the same number under the radical. Namely, I'm going to have a square root of 3, and 4 plus 1 gives us 5 square root of 3. We can subtract them the same way. 2 square root of 3 minus 9 square root of 3. It's going to have a square root of 3 in the answer, and 2 minus 9 is negative 7. Just like combining like terms. But what if they aren't the same? Well, a couple different things can happen. Here's 5 square root of 12, and we're going to subtract from that 5 square root of 3. Wouldn't you know it, it's got a 3 in it again. So the square root of 12, right now we can't do anything with it because the radicals have different numbers underneath. So we have to break it down. And so as we break this down, the 5 will stay. But the square root of 12 is the square root of 4 times the square root of 3. The 5 stays. The square root of 4 becomes 2. The square root of 3 stays. So when multiplying all that together, that's 10 square root of 3. And look at that. If we bring this entire radical down, we're going to take and subtract. We can now subtract these because the numbers underneath or inside the radical are the same. So that leaves us with a final answer of 5 square root of 3. Next, what if we have 6 square root of 2 plus 8 square root of 10? Well, we can't do anything with 6 square root of 2, and 10 doesn't have any perfect squares, so our answer is already in simplest form. We have to leave it alone, and we're done. For our final trick, how do you square perfect squares? Or how do you square radicals? Well, this is how you do it. Let's take 5 square root of 6 squared. What this really means is I have to distribute that 2 to both. So what's really happening is I'm taking 5 and squaring it, and then I'm taking the square root of 6 and squaring it as well. Now we know that 5 squared actually means 5 times 5, which is 25. And we know also that the square root of 6 squared means the square root of 6 times the square root of 6, which we've learned is just the number 6. So when you square a square root, the radical goes away. I'm left with 25 times 6. So think this is the same as 6 quarters, which is 150. Next, it's time for you to practice. So go and complete the practice, and then after you've paused the video and done the practice, come back and we'll look at the problems together. Okay, so we are ready to multiply. So first thing, we're going to multiply the 2 and the 4. It's going to give us 8. And then we're going to multiply the square root of 5 and the square root of 8, which is going to give us the square root of 40. But if we simplify, 8 stays. The square root of 40 is actually the square root of 4 and the square root of 10. The 8 again stays, but we know the square root of 4 is 2. The square root of 10 stays, and we can multiply the numbers outside the radical and get the 16 square root of 10. In our next problem, we can just subtract because they both have the same square root. So 9 minus 10 is negative 1, square root of 3. Now, I don't need to write the 1, but I do need to keep the negative. Negative square root of 3 would be the best way to write that. 7 square root of 20 minus 2 square root of 15. Well, I can't put them together until the radicals are the same. So I'm going to try to get them the same. 7 stays. The square root of 20 is the square root of 4 times the square root of 5. The 7 again stays, and I do know the square root of 4 is 2, and the square root of 5 stays. This then becomes 14 square root of 5, and now I bring down my 2 square root of 5 and subtract, giving us 12 square root of 5. And for our final item with radicals, we're going to square the 3, and we're going to square the square root of 7. 3 squared is 9. The square root of 7 squared just becomes 7, so 9 times 7 is 63. With anything we've done with radicals, go back, re-watch the videos, and then make sure you ask some questions about the different ways in which we can simplify radicals, because you'll be doing a lot of simplifying radicals and working with square roots as you move on mathematically.